Good day everyone, I am French Lamos Libahenteng, and this video we're going to talk about the related rates. So example, if we differentiate d is over dx is equals to x cubed. So derivation of x cubed is 3x squared dx over So now for related rate problems, you're going to differentiate the equation with respect to time. So let's say if we differentiate d is equals to over rather dt y to the power of 5 is equals to the derivation of y to the power of 5 or 3. That would be 5y to the 4th dy over dt. So let's say if you have this equation, area is equal to pi r squared and you wish to find the derivative with respect to time. So area pi r squared and the derivative of a is simply 1. So 1 dA over dt. So the derivative of pi r squared, so it would be pi, the derivative of r squared is 2r. So but if you differentiate as r with respect to time, you're going to get dr all over dt. So now let's work on this problem. So z squared is equals to x squared plus y squared, then dx over dt is equals to 4 and dy is equals to dt is equals to 5. Then find, this is 5. So find dz over dt when x is equals to 8 and y is equals to 15. So now whenever you have a problem, it's good to make a list of what you have and what you don't have. So we have the value of x, it's 8, so this is 8. Then y is equals to 15. We don't have the value of z, so we don't have the value of z, and but we have the value of dx over dt is equals to 4 and dy over dt is equals to 5. Then we're missing dz is equals to dt. So before we could find dz over dt, we need to find z first, so which we can use this equation to get the answer. So since z squared is equals to x squared plus y squared, we can plug it in. So notice that this equation is associated with the Pythagorean theorem, that is a squared plus b squared is equals to c squared for right triangle. So our x rather is equals to 8 plus, and y that is 15 So 8 times 8, 64. Then 15 times 15, that's 225. So 64 plus 225, that would be 289. So square root. So the answer is, our z is 17. The square root of 289 is 17. So now that we have z, what can we do to find dz over dt? So starting with the same equation, let's use implicit differentiation. Let's differentiate both sides with respect to time, or t. So z squared is equals to x squared plus y squared. So the derivative of z squared is 2x. 2z rather. 2z over dz over dt rather. Then x squared is 2x dx over dt plus y squared is 2y dy over dt. So if we divide both sides by 2, we could cancel all the 2's. So let's cancel 2. So it would be 7. Z is 17. So 17 dz over dt. Then our x is 8. Then our dx over dt is 4. Plus our y is 15. Then our dy over dt is 5. So 8 times 4 is equals to 32. Then 15 times 5 is equals to 75. So 32 plus 75, that would be 107. So 17 dz over dt. So it's divided by both sides by 17. So that would cancel. That would be 6.294. So that this is our dz over dt. So because dz over dt is positive, that means that z is increasing with respect to time. So another example. Find the rate of change if the distance between the origin and a moving point on the graph of y is equals to x squared plus 1 at 2 and 5. If the y coordinate in increasing at a rate of 4 centimeter per second. So let's draw. We have graph that looks like this. And the point is 2, 5, which is probability somewhere over here. There. That the read one. So now we want to find the rate of change of the distance between the origin and the moving point. So the distance between the origin and the point is represented by this line. This is the origin, this line. So if we turn it into a triangle, we can say that this is x. So this is x and y. Then, and the distance, the 2 points, let's call it z. So this is our z. So we have z squared is equals to x squared plus y squared. So we want to find the rate of change, or the distance between the origin and the moving point, since z is the distance between the origin and the moving point. So we're looking for dz over dt. That's what we need to find. So now let's make a list of the information that already have. So we have that x is 2, y is equals to 5 based on the point of 2, 5. So we currently don't know the value of z. So now what about the 4 centimeter per second? What variable does that represent? So notice that it's associated with the y coordinate and it's a rate. So that would be dy over dt is equals to 4. So now what about dx? Do we know the value of dx? So we don't know the value of dx over dt. So we're missing that information too, so we can get to find it. So first, let's find z. So using this equation, z squared is equals to x squared plus y squared. So our x is 2, then our y is 5. So 2 times 2 is equals to 4, then 5 times 2 is equals 5 squared rather. 5 times 2 is equals to 25. So 24 plus 25 is equals to 29. Z squared. So square root. So we have square root of 29. So now we have the equation y is equals to x squared plus 1. So we can use this equation to find dx over dt. So if we differentiate both sides with respect to time, we're going to get dy over dt is equals to 2x dx dt. Then our dy over dt is 4. So then our x is 2. Then dx over dt. So 2 times 2 is 4 dx over dt. Then let's divide both sides by 4, so it will be 1. So our dx over dt is 1. So now the only thing that we're missing is dz over dt. So that's what we're trying to find. So we get that we have the answer to the problem. So let's use the original equation, or not the original equation but this equation. Z squared is equals to x squared plus y squared. So and let's differentiate both sides with respect to time. So the derivatives of z squared rather is 2z dz over dt. Then the derivative of x squared is 2x dx over dt plus the derivative of y squared is 2y dy over dt. Then cancel all the 2's. So z is square root of 29 dz over dt. Then x is 2. Then dx over dt is 1 plus our y is 5. Then our dy over dt is 4. So 5 times 4 is 20 plus 2 is 22. Then square root of prime. So it's we have dz over dt is equals to 22 over square root of 29, or 22 square root of 29 all over 29. So this is our the dz over dt.